Hi everyone, welcome to my presentation titled Whose Health is Affected by Climate Variability, Evidence from Household in Rural Uganda. My presentation will narrow down to rural children. My name is Emily Injete Amondo. For my outline of presentation, I will take you through introduction to conclusion. To motivate the study, we start by explaining how climate change and variability affect health, and it does so through two major ways. First, by exacerbating the already existing health condition, and secondly, it introduces additional new health risks to the existing burden. The mechanisms through which it results into this are also two, direct and indirect. Directly through extreme weather events such as drought and floods that results into injuries, death, and sometimes mental stress. And indirectly, weather and climate affect the key determinants of human health, that is air, food, water, and disease vectors. It's projected that most of the health impacts of climate change will occur in the future. The present diagram shows the different health impacts of climate change. We are interested in undernutrition, and presently we can see the magnitude is not quite high. But as we move through different time periods and different climate scenarios, we see the magnitude of undernutrition projected to increase largely. And despite all this, there is also potential for risk reduction through high level of adaptation. We focus on children because they bear approximately 88% of the disease burden, and undernutrition does not only have severe consequences on children's cognitive and physical development, but also on future income and educational levels, given that some of them are irreversible. UNICEF estimates that approximately 160 million and 500 million children are residing in areas with extreme weather events. And with continued increase in negative climate event, it could possibly reverse the achievement that have been made in stunting reduction, given that stunting is very sensitive to weather shock and climate anomalies. My research question, I focus on how does extreme weather events, both precipitation extreme and temperature extreme, affect children health outcomes. We go further to look at what are the possible transmission mechanisms. First, we look at agriculture pathway, and then later we'll look at disease pathway. For agriculture, we focus on crop output and livestock because most of the rural farmers, they practice what is called mixed farming. They depend both on crop and livestock for food and also income. And most of their farming system is largely dependent on rain-fed agriculture. For disease pathway, we focus on child diarrhea because majorly nutrients are lost through frequent diarrhea episode, and also nutrient absorption and food intake is reduced with diarrhea. Thus, it impairs weight as well as height gains. We focus on Uganda. Uganda is in East African region, and the region is also quite sensitive to weather shock. In the recent past, there has been increase in frequency and intensity of floods. And climate trends over 30-year period from 1986 to 2016 reveals that annual rainfall and temperature in Uganda has not been quite stable. For instance, the lowest rainfall was experienced in 2005, and the highest temperatures were experienced in 2002 and 2009. We focus on different secondary data sources. Our agriculture and household socioeconomic information comes from Uganda National Panel Survey, which is part of World Bank Living Standard Measurement Studies. In particular, we focus on 4 webs running from 2009 to 2014. The advantage with the data sources is that they are national representative and households location-wide georeference, which enables us to match each household with rainfall and temperature data. And our rainfall comes from climate hazards group infrared precipitation with station data, while temperature is from moderate resolution imaging spectroradiometer. The advantages with the two weather data sources is that they are both global and their temporal extent is also quite good. They also have high spatial resolution, and they combine satellite as well as in situ station rainfall data. Therefore, we download high-frequency monthly data, which is used to construct our objective weather variables. And we do this by constructing the statistical z-scores, where we get seasonal rainfall and temperature variability from the long-term mean. We use FISNet seasonal calendar to define the respective months for each and every season. Thus, we come up with two major variables, that is heat wave counts and a rainfall categorical variable with both extremes of rainfall. We also consider different time period because some of the nutrition measures are as a result of past nutrition deficiencies or diseases and also past weather shock. Thus, we consider first lag, fifth lag, and a 5-year count of both a heat wave and dry spell. And for a short-term nutritional measures, that is what we consider previous season variables. We also consider subjective, that is dummies for drought and flood. And our outcome variables are the different z-scores for the undernutrition measures. These are spatial temperature maps for different sub-regions of Uganda. And as we can see, northeastern Uganda and southwestern Uganda are experiencing high temperature in 2009 and 2010. The figure also shows the distribution of mean height for age z-scores vis-a-vis the different categories of rainfall. As we can see that children that resided in places where rainfall was moderate dry and extreme dry, they had lower mean scores as compared to other rainfall categories. And for temperature and undernutrition, we find that percentage of children stunted, underweight, and wasting vis-a-vis heat wave counts reveals that when stunting was highest is when the heat wave was highest. For empirical strategy, we use panel fixed effects, and our main coefficient of interest is beta 1. We control for other child characteristics, household characteristics, and also coping strategies. And for our results, we report results for all children and for subsample of children in at least 3 waves. And we find that heat wave, extreme dry spell, and extreme wet spell had a negative effect on her scores. The same effect is also shown on weight for height z-scores. Even though weight for height z-scores we considered previous season and not previous year. For a 5-year cumulative measure, we find that heat wave and extreme dry spell had negative effect, but the significant effect was only experienced on heat wave. And then for the 5th lag of extreme dry spell, we also see a negative and significant effect on hers and was. Controlling for different adaptation coping strategies, that is ex ante use of saving and ex post change of diet, we find that saving had a positive effect on hers, while involuntary change of diet had a negative effect on hers. Using self-reported drought shock, we find that drought shock had a negative effect on all undernutrition measures, while the ex-ante use of saving had a positive effect on the different anthropometric measures. For transmission mechanism, we start with agriculture pathway, and we plot crop output against a number of high temperature months for different regions of Uganda. And the graph shows that northern region, which experienced high temperature months, is the region that registered low crop output. For our regression, we find that the subjective drought shock, objective extreme dry spell, rainfall coefficient of variation, and heat wave had negative effects on crop output. And for the household that engaged in different adaptation strategies such as water harvesting, crop diversification, and improved input use, registered positive or improved crop output. For livestock ownership, we find that extreme wet spell and rainfall coefficient of variation had significant effect, but then heat wave, drought shock, and flood shock subjective measures, they didn't have any effect. These results are consistent with a study that was conducted in Tanzania, where it was found that temperature shocks did not have any significant effect. And our last pathway is disease pathway, that is child diarrhea, and controlling for water sanitation and hygiene. We find that rainfall and temperature of the previous month before the interview had a positive effect on the probability of diarrhea. while annual average temperature heat wave extreme dry spell also had a positive and significant effect on probability of diarrhea, given that some of the disease-causing pathogens of diarrhea are also climate sensitive to, especially to temperature. This partly explains why we have this effect. And also during periods of extreme dry spell, there is water shortages, thus water quality and quantity is compromised, which also further compromises the intensity and frequency of sanitation and hygiene practices. In conclusion, we conclude that crop output and child diarrhea were the major mechanisms, and even though there was significant association between weather and climate measures with children health outcome with right adaptation strategies, the negative effects of climate change on health and on agriculture are smoothened. Therefore, we recommend ex ante or anticipatory adaptation strategies such as precautionary savings, water harvesting, crop diversification, improved input use, and improved wash conditions. Thank you.